Hello to everyone. Um, Very warm welcome to the DLD lecture 1, that is parallel ladder and triple ladder. Okay, in this lecture I am mainly focused on the purpose of parallel ladder or triple ladder is one of the application of full adders. By using full adders we may construct a different number of adders. So the one of the application is parallel ladder and triple ladder. The another name also parallel ladder is triple ladder. And second application is parallel subtractor. Okay, so in this lecture the main objective of this particular video is what is the meaning of parallel ladder and triple ladder and the purpose of parallel ladder and triple ladder, and similarly the parallel subtractor and advantages of parallel subtractor and disadvantages of parallel ladder and parallel subtractor. Okay, so first of all, what is the meaning of parallel ladder and triple ladder? Okay, so it can explain with the help of circuit diagram. So I am taking the first from the circuit diagram. So hereby I can explain the purpose of parallel ladder and triple ladder. Okay, so here if you can observe how many number of full adders you will see. So here n number of full adders are there. Okay, that is 1, 2, 3 and n minus 1 and n. Okay, so n number of full adders are there. Okay, and next in all n number of adders are consisting of three inputs A1, B1, C1, and it produces two outputs S1, C2. Similarly, for this full adder 2, it is consisting of again three inputs A2, B2, C2. Here the C2, which is the output, which is the common terminal for both the full adders FA1, full adder 1 and full adder 2. Okay, so you may say clearly here full adder 1, full adder 2. Okay, so in this full adder 1, the output of C2 which is connected to input of full adder 2. Okay, input of full adder 2. Similarly, the output of C3 which is connected to input of full adder 3. Similarly, the output of C4, that means full adder 3, that is output of which is the output of full adder 3, which is connected to the another full adder input as a input, that is FAN minus 1. So like this way, so here all n number of full adders they are connected in such a fashion, and the connection is called as cascading. What do you mean called as? We are called as cascading. So here the full adders are connected in cascade. Okay, by using one of the output is carry. Okay, so here in this structure n number of full adders are there. So how many number of bits are consisting, and such number of full adders should be presented. Okay, now see, if you are supposed to construct 4-bit full adders, 4-bit parallel adder, okay, you need to consider 4 full adders. If you are supposed to construct 2-bit parallel adder, you need to construct 2 full adders. Like this way, so this is the circuit diagram which is supposed to construct n number of bits of parallel adder. Okay, now we are going to discuss about the working principle of this full adder. Okay, and this can be explained by considering one of the example here. Okay, now I am considering A1 as 1 and B1 is 0. Okay, so no, I am writing here only. Okay, so what is the output? My A input is 1 0 1 1. My B input is like 0 1 0 0. So in this output my A0 is 1, my A1 is 1 and A2 is 0. Okay, and A3 is 1. A3 is 1 and A4 is, this is A4. Let us assume this is A4 and this is also 1. Similarly, I am taking B. B is 0. So my B1 is 0. B2 is 1. B3 is 0. B4 is 0. Okay, so these are my inputs. And here I am not taking any value of C1. So I am considering the value of C1 is 0. Because of the output of full adder which is connected to one of the input of full adder 2, so I need not to consider the value of C2. I am considering only the first bit, that is C1, that is equal to 0. Okay, you may consider the value of 1 also, no problem at all, but just I am taking the value of C1 is 0. Now as per principle. So here what is the example? 1 0, like 1 1 0 1 1 1. This is example. Let us example. So this is 0. So according to the truth table of full adder, 0 1 0, what is my sum 1? Sum 1 is 0. And what is my, sorry, sum 1 is 1 and carry is 0, because so in 0 1 0 from the truth table of full adder, it produces sum is 1, carry is 0. Okay, and this carry, which is the output of full adder 1, which is connected to the input of full adder 2. So the carry is propagated. Carry is propagated from where to where? From full adder 1 to full adder 2. So now one of the input, already full adder 2 is pursuing two inputs, that is 1 1, is consisting of two inputs 1 1. And after, by getting the output, that is output of full adder 1 0 is input of full adder 2, which is equal to 0. So 1 1 0, what is the value of sum 2? Sum 2 is 0 and carry 1, and the carry is propagated to third full adder. Now the third full adder, the inputs are 1 0 1, and again it produces sum is 0, carry 1, and this carry is moved forward to the fourth full adder. So there it consumes the three inputs 1 1 1, and the sum is 1 and carry is also 1. Okay, so this is my answer. What is my answer? Sum is given by 1 0 0 1 and carry is 1. Okay, so in this case you mainly observe 2 points. Point number 1, the carry is propagating. Carry is propagating from full adder 1 to full adder 2, full adder 2 to full adder 3, and full adder 3 to full adder 4, and full adder 4 to full adder n, like this way. So the carry is propagated. So that's why this 4-bit parallel adder is also called as a ripple adder. Is also called as a ripple adder. Okay. So students, and this is the working principle of 4-bit parallel adder. And why the parallel adder is named so a ripple adder? What is the reason? The reason is the carry is propagated to from one adder to another adder. So that's why it is called as 4-bit ripple adder. So here the number of bits are 4 bits. That's why it is called as 4-bit ripple adder. If number of bits are n, then the circuit is called as n-bit ripple adder. Okay. And the next one is 4-bit binary subtractor or parallel subtractor. Okay, students, so if you want to perform subtraction operation, okay, so it can be done two methods. One is direct method, that's binary subtraction method, and another one is complement subtraction method. Okay, in complement subtraction method, again we have two methods, that is one's complement method or two's complement method, especially for binary. Okay, so here according to the complement subtraction method, and this particular circuit will design. Okay, this particular 4-bit binary subtractor will design. See, when you observe very clearly, what do you understand? So in this circuit diagram, so you can observe one main modification, that is inverting. So in previous circuit diagram, we are not connecting any inverter circuits. But here you can clearly observe the inverters. In previous circuit diagram, we are directly applying B0 as one of the input. But here we are not applying the direct input from B0. Okay, in between full adder to B0, there we connect one input, that is one particular gate, that is inverter. Okay, now what happened here? So B0 is inverted as B0 bar, and in this circuit the C0 is very very important. We are always consider the value of Cn is 1 only. Why? Because so if you suppose this particular circuit will supposed to perform subtraction operation by using 2's complement method. So what is the formula of 2's complement method? 1's complement of a number plus 1. Okay, so based on that one, so in this case this particular circuit will supposed to perform subtraction operation by using 2's complement subtraction method. So we need to convert B0 as B0 bar, and which is should be added with 1 only. So that's why the value of Cn0 is always considered 1 only. This is very very important point. Okay, so once you consider C0 value 1, the B0 bar which is added with this 1 and which becomes 2's complement of B0. 2's complement of B0, and which is added with this B0. Okay, similarly A1 and b1 which is inverted by b1 bar, okay, and which is added with this cn1, which is added with this cn1, then it becomes 2's complement of b1 which is added with this a1. Okay, similarly, like b2 and b3 are same way they are performed by 2's complement subtraction method. Okay, once the b0, b1, b2, b3 all are converted into 2's complement 2's complement form, and those 2's complement form are added with this a0, a1, a2, a3. Okay, so by using full adder concept. So what is the comparison between parallel adder and parallel subtractor? So the comparison is very clear. In parallel adder, we are directly applying inputs to the full adders. But as in parallel subtractor, so instead of giving the direct inputs, we need to apply 2's complement method with the help of Cn1, that is Cn should be equal to 1, and that's B0, B1, B2, B3, so they are applied to NOT gates. Okay, so this is the operation of 4-bit binary subtractor. Okay, so and let us discuss about the advantages of parallel adder subtractor. Okay, so from the circuit diagram, the parallel adder or subtractor performs the addition operation or any subtraction operation which is faster as compared to serial adder subtractor. Okay, so what does it mean? In parallel adder subtractor, we are applying the inputs simultaneously. Okay, whereas in serial adder subtractor, we need to apply the bits one by one. Okay, and next one, the time required for addition does not depend on the number of bits. Okay, so in this case, the time required for addition, so either addition or subtraction, the particular circuit does not depends on time. You can supposed to apply any number of bits. Okay, so never supposed to depends on the time. And next one, the output is in parallel form, that is all bits are added or subtracted at the same time. Okay, and the another one is it is less costly. Well, coming to the disadvantages. In disadvantages, each adder has to wait the carry which is to be generated from the previous adder in chain. Yeah, this is the major drawback of parallel adder subtractor. Okay, so each adder has to wait for the carry which is to be generated from the previous adder chain. Okay, so for the operation of full adder, and in any stage, it should be waited for the carry, and the carry is the output of the another full adder. Okay, so that's why each adder has to wait for the carry which is to be generated from the previous adder, and the time, okay, how much of time it is waited, okay, which is nothing but some sort of delay, and the delay is nothing but propagation delay. The delay is called as propagation delay, and the propagation delay is very important parameter, and this parameter is always should be very minimum value. Okay, so if propagation delay is more, that means the performance of the particular circuit is very less. Okay, so here the propagation delay is very high in this parallel adder subtractor, so it is a major or big disadvantage of parallel adder subtractor. Okay, so and the propagation delay is found to increase with the increase of n number of bits. Okay, if n number of bits are there, the propagation delay is n minus 1. The propagation delay is n minus 1. Okay, if n 4 bits are there, and suppose to the propagation delay is 3 seconds. It is an example. Okay, so like this way the propagation delay is also. So that's the students. So far we discussed about what is the parallel adder. Parallel adder used to perform so parallel addition, whereas parallel subtractor used to perform parallel subtraction by using which method? 2's complement subtraction method. Okay, and another one is advantages of disadvantages. Okay, so this is one of the topic in our third unit. Okay, I hope you understand. If any doubts, just ask me in our WhatsApp group. Thank you.